everybody. This video is about the bridges of Konigsberg. So it's kind of an introduction to where graph theory started, as well as an introduction to Eulerian paths and circuits, which you can use on future assignments. So go ahead and take 3 deep breaths, and let's make this math easy. All right, so this picture is a picture of Leonhard Euler, who was a mathematician that lived in the 1700s, and he's considered to be the father of graph theory. And he actually did tons of mathematics in lots of different fields, but he's one of the first who kind of started the idea of graph theory. So the way that the legend goes is that the way that he first came up with the first graph theory problem was he was visiting this city called Konigsberg, which is modern-day Kaliningrad in Russia. And in Konigsberg, there's a river that flows through the city. And they had built bridges that are shown here with these little green marks here. And he was just thinking about it, and he was like, I wonder if it would be possible to cross every bridge exactly once. Like to go on a walk through the city and cross every bridge exactly once and get back to where I started. So that was the question he asked himself, just out of curiosity. And from that question, graph theory was born. Because as he was thinking about it, he realized, like, well, technically, like the route that I take through the different islands or different land masses on the city, that route doesn't really matter for the question that he was asking. Because he was wondering, is it possible to cross every bridge exactly once? And it doesn't really matter which streets you take if you're only worried about crossing each bridge exactly once. So he kind of simplified the diagram or the picture of the city and said, okay, well, instead of like having all these detailed streets and all this kind of stuff, I'm just going to draw like kind of big lumps for each landmass. So he had the North Bank, the island, the South Bank, and the East Bank. And then he connected these land masses with lines that represented the bridges between the different land masses. And so in modern day graph theory, what he simplified this to is what we call a graph, where you have the 4 different vertices that represent the North Bank, the island, the South Bank, and the East Bank. And then we have edges that represent the bridges. And so this is why Eulerian paths and circuits are called that, because they're named after Euler, because Euler was the one that first came up with this problem. Because when he was asking, is it possible for me to go on a walk through the city and cross every bridge exactly once? What he was really asking in graph theory terms is there an Euler circuit? Because remember, an Euler circuit is a circuit that goes through every single edge exactly once. And since the edges were representing bridges, that's the same thing as asking, is it possible to cross every bridge exactly once? And then because he wanted to end up back where he started, that would be a circuit. And so that's why we call them Euler circuits. So this is something you guys are going to explore on your in-class assignment to see if it's possible to cross every bridge exactly once. So I'm not going to tell you the answer of whether it's possible or not. That's something you guys get to explore. And then you'll also explore some other types of graphs that maybe don't represent a specific city in Russia, but we're still looking at the same idea of, is it possible to cross every edge in the graph, whatever the edges represent, whether they're bridges or roads or whatever they are, is it possible to cross each one exactly once to find an Euler circuit or an Euler path? So as you go into that assignment, just a reminder, An Euler circuit is a circuit that uses every edge exactly once. So like if I was looking at this graph, an Euler circuit might be one where maybe I start at B, then I go to A, to D, to E, then maybe back to A, then to C, E, F, C, and B. And because that circuit uses every edge exactly once, that makes it an Euler circuit. And you can also have Euler paths. Remember, a path, it can be a circuit if it starts and ends at the same place, but an Euler path doesn't necessarily have to start and end at the same place. So I could maybe like start at B and go to A, then to C, then to B, then to D, and then to C, and that would be an Euler path. And a lot of graphs will have more than one, so that it's not like there's just one right answer. The main thing we're looking at is it possible to do an Euler path, or is it possible to do an Euler circuit? Because there's some graphs where it's not possible. So that's what you'll be exploring in your in-class assignment. And if you have any questions, let me know.